So, this is the AB1 problem, and we are given the function x to the third minus 7x plus 6. And part A of the problem says to find the zeros of f of x. So basically all you have to do is plug in 1 for the x into this, and you get 1 minus 7 plus 6 equals 0. And then you factor it, and you do x minus 1 intercept to x minus 1, and then x squared plus 6, and then you FOIL that out, you get x minus 1, x minus 2, and x plus 3. Therefore the zeros are 1, 2, and negative 3. Part B, you're supposed to find the equation of the tangent line at x equals negative 1. And so you use this formula right here, is y minus f of negative 1 equals f prime of negative 1 times x plus 1. And the way you get these values for f of negative 1 and f prime of negative 1 is you come over here and you plug it into the original equation you got. If you plug in negative 1, you get negative 1 plus 7 plus 6 equals 12. And then f prime of x you do by getting the derivative of this original function is 3x squared minus 7, and when you plug in negative 1 to the derivative, it's 3 minus 7, and that equals negative 4. And so you get those values and you plug it into this equation, so it would be y minus 12, because that's what you got right here for that, and equals negative 4, x plus 1, and negative 4 is what you got for this value here. And or you can get y equals negative 4x plus 8, and that's just a simplified version of this right here. So let's find the number c that satisfies the conclusions of the mean value theorem on the function from the interval of 1 to 3. So you take the derivative of the function of c, and that is f of 3 minus f of 1 over 3 minus 1. That's the mean value theorem equation. And of course from the intervals of 1 to 3. And then you find the function of 3, the values for it. So it's 27 minus 21 plus 6 equals 12. You get that for plugging in the original equation, the 3. And so you substitute, and then for f of 1 you get 0, and that's from the equation. And then you substitute the values in and you get this, and that equals 6. So then you have this that equals 6, and you set 6 equal to this equation, and it's 3c squared equals 13 because you just add over this 7. And so c squared equals 13 over 3 because you divide the 13 by the 3. And on the integral from 1 to 3, and therefore c equals the square root of 13. This is a particle problem. The particle moves along the x-axis in such a way that acceleration from at time t for t is greater than or equal to 0 is given by at equals 4 cosine 2t. At the time 0, velocity of the particle is 1, and its position is 0. Write an equation for the velocity of the particle. So you're given the acceleration, so you have to do the antiderivative of the integral of the acceleration equation in order to get the equation for velocity. So you get to right here, and once you take the integral of it, it's 2 sine 2t plus c. And at that point, you have to find the constant for value c, so you plug in 0 to this original for the velocity equation right here. And so when it's 0, it equals 1. So then when velocity is 0, x equals 1. So then you set 1 equal to 2 sine 0 plus c, which is the original equation right here. Or no, the one you took the integral. And then you end up getting a constant of c, so the final equation for velocity is v of t equals 2 sine 2t plus 1. For part B, it says write an equation for the position of x of t of the particle. So you take the x of t equation, which equals 2 sine plus 2t plus 1, what you found here, and you take the antiderivative of that. So then you end up getting negative cosine 2t plus t plus another constant. And so you have to find that the other constant you have, so like you did before, so they plug in 0 for the original equation. It equals 0 there, so negative cosine 0 plus 0 plus whatever the constant is equals 1. So therefore, the constant is 1. And then here's your final problem, or final answer for the equation. For position is x of t minus cosine 2t plus t plus 1. For part C, you're trying to find what values of t between 0 and pi is the particle at rest. And so use the particles at rest whenever v of t, this velocity, equals 0. So whenever v of t, the equation we found for v of t, or velocity, is 2 sine 2t plus 1 equals 0. So whenever sine equals 2t, sine of 2t equals negative 1/2. So at 2t, so then 2t equals 7 pi over 6 or 11 pi over 6. Or 7 pi over 12 or 11 pi over 12. So those are the integrals because that's whenever the velocity intersects the x-axis at 0, if you graph it.
I should be doing a calculus video, but look at this puppy! Ah! He's so cute!
Film that, and then that's the real.
This is my project. You don't need problems. You need more puppies. Can I get a come on? He likes my shoelace.